we go. Yes, stand out in the hallway, check with your classmates, see if your answers match up. Sometimes the answers will be different, especially in this class towards the middle and end. I want to have you guys running a bunch of what are called computer simulations. We're going to start today if time allows. We're going to see how much time today takes. I'm not exactly sure how it's going to go. But either today or Monday, we're going to give you guys a TI program. That's why I need the cord. I have to go get a cord so I can share it with you guys. We're going to do some mathematical simulations. And even if we don't get to that part, I'm going to have you guys flipping coins and rolling dice and keeping track of data. Well, you can tell right away if two people roll a die 6 times each, are they going to get the exact same thing?
No.
Could they get the exact same thing?
Yeah.
Is it likely?
No.
Exactly. It's not likely they're going to get the exact same thing. Those 6 trials, even one trial, it's only 1 in 6 likely to get the exact same thing, and it gets worse as you do more and more. So when you're comparing answers, realize that. Sometimes you're going to have different answers, but the idea is the process. Is your process valid? Does it compare with your neighbors? Even if if your neighbors is different, is theirs valid? Talk to each other, really. That's one thing that makes me nervous about mathematics classes in America, is my son's 6, and last night we were playing this kind of marble-based Sudoku game. I think it's pronounced that correctly, you know, the little 1 through 9 puzzle. And he's 6, so he can't quite figure out Sudoku yet. I'm going to try it on tonight during the service, see if that works. But he was making up a variant of it, and he was so excited about the logic of, making sure each of the 9 spots had 1 color each. So I just dump all the marbles in. I'm like, okay, let's go. Which one? There's 2 reds there. So he'd take 1 red out to put it in his hand and then find someone else without a red. And just watching his logical process, I'm like, that's awesome. He was stoked about it. And he got more pizza and came back and wanted to play again. Somewhere between that and senior year of high school, something happens. Right? And exactly. You all have, I'm sure most of you have felt it. It becomes almost a drudgery to do mathematics and logical thinking. And part of what we try to do with this class in the 243 and 244 is kind of flush that out and bring back an excitement about discovery, figuring out the world via numbers in mathematics. This quiz will not feel like that, FYI. This quiz is very algebraic, very computational, kind of like blah, 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 blah. But it's kind of like a base set of skills that I'm kind of hoping that you have coming in, so we can build off of that with some estimation skills and things. Yeah? Good morning. Yes. Hi. Okay. So anyway, that's the quiz for next week. We're still recording. I just got the note. The camera did shut down a couple times, I remember, on Monday. It didn't shut down yesterday, but I wrote a note yesterday to my dean and got the okay to spend some college money and get a better camera. I'm discovering that a GoPro isn't the best camera for recording class. It's pretty good for skydiving and stuff like that, but not so good for sticking on a stand apparently and recording classes. So over the weekend, I'm going to go. Where should I go to get a video camera? What's the best place?
Best Buy.
Best Buy? Best Buy? Okay. Somebody said Best Buy with a warranty. They'll just replace it if it ever fails. Okay.
Walmart, obviously.
Walmart? No. Okay. Okay. We'll hash it out at break. So anyway, there's the quiz for next week. There may be a second one. If there is a second one, I'll describe each one on there. Otherwise, I just put quiz due. And then that's it. What questions do you guys have after going home and kind of processing the whirlwind that was Monday? Anything come to mind? Anything you're concerned about? Anything you're nervous about? Please tell me your name again.
Shelley.
Shelley?
The homework.
Yes, ma'am.
I started it and
That's
I was
okay.
lost.
You didn't have to start it at all because we didn't talk about anything on Monday except the syllabus.
I figured that.
That's okay. Shelley asked a very, very good question as far as when homework is due, because there are no dates on anything, correct? There are no dates. So let's turn the question around to you guys. Excuse me, puberty. Turn the question around to you guys. How will you know when homework is due? Please, Tori.
It'll be, I would think, the next class following after we lecture about it.
Very, very good. Very, very good. Now that's a traditional answer, and it's a perfectly acceptable answer. Yes. In class, I have. Let me show you the homework sheet again here. Shelley asked a very good question. Tori's got a perfect answer for it. So here's the topics that I would like to get through on 105. We might get to all of them. We might not. I mean, I think we'll probably get the ones that are highlighted. I'm not sure about these. I have to write them first and get them kind of dialed in, and then we'll see. But anyway, we're going to start that estimation one today. Let's say I finish it. And when I say finish it, I don't mean finish it. I mean, I get through kind of the examples I wanted to run, and we get through these in-class quizzes, and we kind of hammer out, and I get the feel that you guys are kind of, all right, you're ready to try some of these on your own. Then I'll verbally say, okay, go home, try the estimation homework for next time. Then you'll go home, take out that homework sheet, also picture me on the bike, and then you'll try those questions, which hopefully won't feel so lost once we've discussed this for an hour or so, or 3 hours in class. Then you'll come back next class with questions. In addition, I promise you that if that happens today, in this cell right here, I will put, we finished the estimation lesson, and I'll hyperlink the estimation. Please bring questions on the homework, and I'll hyperlink that to the homework to next class. Does that make sense? So you'll know in a couple different ways. I'll verbally say it in class, and I'll also post it on the schedule page. So you can always get the info here. And today begins the first day where there's nothing in the box, because I'm not exactly sure how the day's going to go as far as how far we're going to get. Make sense? Great question, Shelly. I'm sure that half the class was thinking the exact same thing. Like, there's no due dates. Like, how do I know when stuff is due? And that's how. You'll know kind of at each day when stuff. Does that make sense, everybody? Is that fairly clear? Yeah. And you can find the homework sheet. Can't see it right now, but and I'll keep linking it for the first couple weeks. I'll link it in the schedule so you can find it. Any other questions? That's a fantastic good question. Tell me your name.
I'm Kirsten.
Is that your A2? What happened?
What?
Is that your A2 pulley with oh no, that's a fingertip cut, isn't it?
Yeah.
Yeah, there he goes. Kirsten.
Kirsten.
It says somewhere in there that you won't go over every kind of problem.
Every kind of problem, because if I did that, we could spend 6 hours going over every single problem.
If I have a problem, I can ask in class out loud and you'll...
Yes, yes, I beg people to ask questions in class. Historically, what has happened when I ask for homework questions in class is I met with dead silence. Or I'll get like one question. You got a question, Kirsten, you ask it. And I know part of this is my homework policy. Because I don't collect homework, people, I'll just catch up with them on the weekend. I'll catch up with them on the weekend. And that's okay, as long as you do. But realize that two things are working against you there. If you don't have the stuff due by the day I'm expecting questions on it, like Kirsten's asking, number one, you're going to miss the discussion that we're having. I mean, you'll be here for it, but you won't have actually tried anything, so that won't make as much sense to you. And number two, historically, when I've talked to people about that after the fact, do they actually catch up on the weekend?
No.
Life gets in the way. Stuff happens, right? We get finger cuts or A2 pulley blows, or Max has to go do something this weekend, I'm sure, which I haven't heard about yet. So try to stay on top of it. Even though I'm not collecting it, that doesn't mean don't do it. That doesn't mean don't do it. Yeah? Okay, good question, Kirsten. Thank you. Anything else? Well, so far? All right. So speaking of Max, I'm going to let him lead the way here. This is Max in my 40th birthday present, which was my hot tub. Love my wife. Yeah, it's pretty amazing. Felt pretty good. I turned 40, got a great beard. I was like, this is awesome. And I beat the crap out of myself physically. I mean, swimming and running, biking and everything. And, by the end of the week, total fit, Jenny, I'm not sleeping, and she's got me running 8,000 miles a day. And, all I want to do is like soak, and then this is my present, so I was totally stoked. And I learned pretty quickly after about a month of not taking care of it that you have to put chemicals in it. Anybody has a hot tub knows this. I know this now that I've caught up to it. And this particular day, the water looked kind of murky, and Max didn't care. He's in it. That's my 6-year-old, Max. And he was in it, and I was like, Max, get out of the hot tub. I gotta figure out how much of this. It's called Bright and Clear, or some kind of chemical that had to go in once a week. Now that I understand that, he's like, no, Daddy, I'm having a good time in here. I'm like, dude, it's like 85 degrees outside, and the tub's 104. Get out of the tub. You can get back in. It's a summer day. Go run around. Go in the hot tub. So I figured, all right, I can figure this out while he's in it. So I grabbed the bottle, and the bottle had a code on it. It said if your hot tub is up to a certain number of gallons, put in 3 ounces. And if it's above a certain number of gallons, put in 4 ounces or something like that. I have the instructions later. So my job was to, without running inside to check my phone or check the internet or what, figure out how many gallons of water were in that hot tub. Close enough to be able to put the correct amount of chemicals in. So what I had to do was something called estimation. That's what today is going to be all about. As soon as I find my pen, I'll write that down. I had to estimate. What does estimate mean? How many of you ever estimated something before? Good. And if you have, what have you estimated? Tell me your name again. Benji, what is estimation first off?
Estimation is where you give your best guess.
Good. Very nice. Very nice. I want to
And I've estimated, the amount of time it'll take me to, get from San Francisco to Berkeley.
Good.
Hey, it's Valentine's Day. Who knows what the traffic,
Good. So an example that Benji's estimated is San Francisco to Berkeley, which are right next door to each other.
Yeah.
And I say right next door to each other, literally, but not figuratively. It's not traffic-wise. You're on Valentine's Day.
Yeah.
Taking public transit, driving yourself.
Drive myself.
That's even trickier, right? And you can't use the schedule of the public transit.
Which I normally do, takes me.
Exactly, so you have to estimate, that's another thing you have to estimate, you have to figure it out. If I leave Juniper in the morning after I swim Masters, how long is it gonna take you to get up here, get cleaned up, ready for class? I have to estimate that, otherwise I'm gonna be late for your class. And I know that would make you very happy. But, I'm gonna do everything I can to not do that. Who else has estimated something? Or give me a definition of what an estimate is, Micah?
Food orders when I was a restaurant manager.
Food orders, meaning how much you should order.
How much I should order.
We got time. Things to order, okay, so give me more.
Projected sales for that particular period, 3 days or 4 days.
When you say projected sales, what are you projecting it off of?
Last year plus, so last year's percentage increase for that time period plus what I've done the past, an average of the past 6 weeks.
Okay, so historical and
Yes.
more recent history.
Yes.
This is good. Mike is actually describing something called mathematical expectation, which is something, a big part of this course, which we'll eventually get to. It explains why Vegas can keep its lights on 24/7 and still make money even though there's no water in the entire region. Yes, it's all based on mathematical expectation and people not understanding it. Thank you. Benji, how did you estimate your time?
So, normally, to get to my friend's house, it'd take me 30 minutes. But I assume, you look at the traffic report, and, I assume double.
Okay, double the time it would take you,
Yeah.
so an hour.
Yeah.
Ballpark an hour, good. And sometimes with things like that, I'm assuming that an overestimate isn't a problem. If it takes you an hour,
Yeah.
not a big deal. You just get there a little bit later.
Yeah,
Yeah.
grab a copy.
Right. Estimation gets a little more critical when you have to worry about being bookended on both sides by a schedule up and a schedule back. But this is a great example. Go ahead.
Worst case scenario of overestimating, you play Angry Birds in your car outside your door for, 15 minutes.
Not bad, not bad.
And underestimating, critically worse.
Max is a huge fan of Angry Birds, Star Wars. That's his favorite.
Angry Birds fruit snacks now.
I don't know.
Blows my mind.
We're going to analyze Angry Birds in this class too. It's a perfect example of quadratic modeling, so we'll get into that too. We have to play it here. It's the one thing I have to work on. I'll work on that next. We're going to analyze it. Good. What else have we estimated? Or who wants to tell me what an estimation is? Who wants to share? I want to come back to that speed one because there's a good one you can do in the car. Oh, there's more hints to that. Please, tell me your name again.
Linda,
Linda, thank you.
when I'm baking or cooking or something, I estimate what I need to put in there. I don't really measure, unless it's specifically,
My grandma Mary never did either.
yeah, I just do it.
She used to say, you know when it feels right? I'm like, I don't know.
Yeah.
I'm only half Italian. Yeah, so you estimate. Can be tricky. If you're making something that's got a very specific recipe. But if you're a good enough cook, you can pull that off. You know that a handful of flour is 3/4 of a cup, or you know that an actual literal pinch of whatever cumin is, 1/8 of an ounce or something like that. I don't have that skill. I tend to go by the sound it makes as I drop it in a bowl. It's not a cup. And Max helps me sometimes too, which makes for interesting pancakes on Saturdays. So yes, good estimation. So you see the wide range of this. You can think about the tolerances. Benji's got quite a bit of wiggle room in the time it takes him to get from Berkeley to San Fran, because worst case scenario, he plays Angry Birds outside the door. Speaking of driving, there's a very, very good shortcut you can use in your mind while you're driving. It especially works in places like Eastern Oregon where you've got wide stretches of road. 60 miles an hour is a very nice speed to drive. Now sometimes it's not legal, so be careful. But if you can go 60 miles an hour, why is 60 miles an hour a nice speed to drive to estimate how long it's going to take you to get somewhere? Who knows this one? 60 miles an hour. Tell me your name.
Andrew,
Andrew, why?
it's a mile a minute.
It's 1 mile per minute. It's 1 mile per minute. 60 miles per hour is 1 mile per minute. So if you're going 60, now when I say going 60, I'm implying something. If you're going 60, at that moment, you're going 1 mile per minute. But in order to take that and make it long term, what do you have to do? You have to make sure that you're not just going 60, but that you're what? Maintaining. Tell me your name. Joe, love that. The word average. We're averaging maintaining a speed of 60 miles an hour. Because if you're going 60 for 30 minutes, and then you drop down to 20, then you're not averaging 60 anymore. You're averaging less than 60, so it's going to take you longer to get there. So keep that in your mind as you're driving around. Good. So we've got plenty of wiggle room there. Micah and Linda, maybe not so much wiggle room, because if you're spending money on food, especially perishables, you want to make sure at least your estimate's in the ballpark, and ballpark is loosely defined. Ballpark could be very, very large, could be Fenway sized, could be Elks Field sized. I mean, there's all kinds of different ballparks we have to operate in. Baking is one of those. If you want the cake to rise, maybe you have to be more careful with your estimates. So, good, so we got best guesses. I think best guess is a pretty good definition, honestly. It's not an exact science, and this is where it gets weird when I'm gonna ask you guys today to start estimating some things. Because we're taught in our algebra classes that x equals 2. Right? You solve this equation, x equals 2, or maybe -3, or something like that. And it's funny, we have a clock up in the math department now, and it's set up, you may have seen it if you walk through the new math department, it's got like equations and stuff that equal the hours. So this crunches down to 1, this crunches down to 2. And my brother-in-law got it and said, this is awesome. And I hung it up on the wall and I went through them all. These are great, these are great. And one of my colleagues is like, 9's wrong. I was like, wow, why is 9 wrong? And 9 was this. What's that? I looked at that and I'm like, yeah, it's 9. But it's not exactly 9. It's not exactly 9. Why is it not exactly 9? Why is it not exactly 9? Tell me name.
Jacob.
Jacob, go.
Because it's an infinity repeating decimal.
Pi is not equal to 3.14. It's approximately equal to 3.14. And 3.14 gets you close enough on Earth to make something round, like the lens of that camera, like the wheels on your car. If you need a little bit more, you add a couple more decimals. But this thing does go on forever. 3.1415.
926,535.
Thank you. But what is this ish equal to? It's basically equal to 9. You'll get used to this symbol in this class. You'll get used to this symbol in this class because you have to use this symbol in your lives. Very rarely does anything equal to. Next time you get a chance to do something like this, go through a house that's being built. Okay, how tall are the ceilings in this room? Ish, if you had to estimate that right now. How tall are the ceilings? Both 10 feet? 9 feet? 9 foot, 10 foot, good, good. Let's take a little survey here. Chord. Ceiling height. Okay, take a look at that ceiling. Take a look at that ceiling. Get an estimate for how tall it is. Estimate in your mind.
How tall are you?
I'm 6 foot, just about. Just about. I got a big soul to that. Like 5'11" and a half or something like that. So call it 6. Ish. 6 feet. Okay, so there's 6 for reference. Cool?
Including,
Ten.
not including your.
Oh yeah, not my hair.
A
little more than 6.
Okay. Maybe I should stay against the wall. Push it. Get the hair down.
Now there's
Like
11.
this.
A little more than 10.
All right. We got some estimates. Okay, I got some estimates. Let's hear some estimates.
11.
Okay, I got an 11.
10.
Who says 11? Who says 11?
Shelley.
Let me see hands. I want to keep track. So we got 1, 2, 3, 4, 5. Yeah. And don't go with your gut check. If you see like one person that has the same number as you, the individual, stick with that number. Okay, so we got 5 11s. Okay, other ones?
10.
We got 10s.
10.
And we got a 10.5. That's just good. How many 10s do we have? How many 10s?
10.
All right. How many 10.5s do we have? Got a couple of those? 1, 2, 3. Okay. Other ones.
9.
We got some 9s? 9. There we go. Let's get some 9s. How about 9s?
1, 2, 3, 4.
4 9s. Who else?
10 to 11.
It's between 10 and 11. Should we call it 10.75? How's that? Just to give it a numerical value, because I want to actually average these values, and to give it a sliding scales, we can do it, but I'm going to get 1 point value. So 10.75, love it. And we just got one of those? Who else? Is that us all? Is that us all? Is that
Throw a
right?
9.5 in there.
Let's throw a 9.5. What the hell? Why not?
Right.
All right. So, what's the average of those numbers? If I wanted to get your class's average guess, average estimate of how tall this ceiling is, and I brought a tape measure, we can actually measure when we're done. If I wanted to average those values, this is the first number. I'm going to use this a lot. Yeah, when we look at the homework sheet, one of the lessons that's not hyperlinked yet is called the expected value, or not expected value, measures of center. And the measures of center are taking a whole bunch of numbers like this and finding their average or their median or their mode. So let's find the average of this. How would you find the average guess? What would you say the average guess was? 10 because why?
Majority.
The majority of people, 10. That's called the mode. That's called the modal guess. The modal guess is 10 feet because most people pick 10 feet. Good. How would you actually calculate the average? Go ahead, Crystal.
You would add together the guesses of height
Mhm.
and divide them by the number of guesses.
Absolutely. So we'd have to add together all the heights and then divide by how many guesses there were. You gotta be careful when you do it that way, because there's actually two columns of data here. There's the guesses that are right here. This is the guess. And this is the number of people that guessed that. So you can't just do 11 plus 10 plus 10.5 plus 9 plus 10.75 plus 9.5 and then add that and divide by 6. Because that would make it sound like there were only 6 people in the class and every single person picked one of those heights. So what we have to do to calculate that average?
Add both of them and then take.
We have to do 5 11s and then 19 10s and then 3 10.5s and so forth and so on and so forth and so on. Now, estimate. What's that going to come out equal to? What is that going to come out equal to on average? What do you think? Estimate.
I
What's
think
that
you
going to
just,
be?
I mean, so you wouldn't just add this line, add that line, and divide it by that one?
There's 3 lines there. So you add the guesses column.
Right, and then add the people column,
Yes.
and then take the people column and divide it by the guess.
Why couldn't we do that? So that's I like that idea an awful lot better. So Linda's saying, why don't we just take the guess column, 11 plus 10 plus 10.5 plus 9 plus 10.75 plus 9.5.
Those are combined.
Take that, add those up, whatever that ends up being, divide it by 5 plus 19 plus 3 plus 4 plus 1.
You're combining everybody, which makes it seem like there's only one whole guess, right?
In the top number, yes. The bottom number actually accurately represents how many people guessed a number in this class, right? If you add up 5 plus 19 plus 3 plus 4 plus 1, that's how many people are actually in the room, correct? Does that make sense? But if you don't do something similar up top with the 11s and 10s and 10.5s, you haven't accounted for all the people that said 11. You only accounted for one person that said 11, or one person that said 10. Check it out. Do that. You got your calculators with you right now? Do this. Do exactly what Linda said. I think what I'm saying is not clear enough, and I apologize for that. If we actually do this out, I think we'll see it more clearly. And I'll fire my machine up too. Do it with me. Plug this bad boy out. Believe it or not, this has something to do with your guys' academic record, believe it or not, what I'm asking you to do right now. And I think if you put it in that context, you'll understand what's going on with this. Is that ish clear over there on that board? You guys hear? There's some numbers. Can you guys hear? See that okay? Is that we're creating next. We're creating next. That's not good. Let's put it, I'll put it right here for right now. How about over there? Is this okay? Just decent? Okay. So, what we're going to do is we're going to add up the numerator. 11, 10, 10 and a half, 9. 10 and a half, 9. 10, 7, 5, 9.5.
67.5.
There we go. And we're going to divide that by the sum of the denominator, or the sum of the numbers that people have guessed, or the people in the room. 24, what do we got? 24, 32? Is that 32?
You have to add another one to the 9.5 though.
Yeah, that's
Oh, I didn't write a 1, did I? Thank you, guys. That's 33, isn't it? Hey, I wrote the 9.5. I forgot to indicate that one person guessed 9.5. Thank you. So that's 33, right? Cool so far? All right. What's that mean? That means on average, our class guessed that the ceiling's height is right about here. 1.8 feet. It's like being John Malkovich, minus the Jersey Turnpike part. So what happened? That math sounded great. What happened? What happened? That math sounded awesome. It did. It's perfect. Except for one tiny thing.
There were 6 entries divided by 33.
You have to have the same number of entries up here as there are people down here, because each person has to have an entry associated with them. I think we can fix this relatively quickly. I think we can fix this calculation relatively quickly. So watch this. You may have learned this trick in 95. I hope you did. If you didn't, press second, enter. What that does is it recalls the last thing you typed, and then you can go in and edit it again. Because I don't want to have to retype all that stuff again. It's pretty good the way it is. I have to adjust it. So if you press second enter, it pops you back into edit mode. Does that sound familiar? How many of you knew that trick? Well, very few of you. That's kind of a bummer. Well, now you know it. Now all of you know it. So yay. Second and enter. And if you keep doing second enter, it calls up the last few things. Estimates the program. I'll read you guys in a little bit. Obviously, I ran it a bunch of times. It does like 20, I think. There it comes. And holy crap, it's more than 20. There it is. So, what should I do up here to fix my calculation of our average guess? What do you think? What do you think? What should I do to fix my calculation? What should I do to fix it? I have to do what Benji said. I have to make sure each person is accounted for. So how can I fix my calculation to make sure each person is accounted for? Let me hear somebody. Tell me your name again.
Andrew,
Andrew, yes, go ahead.
multiply each one.
How about it? One way to do it would be 11 plus 11 plus 11 plus 11 plus 11. Or we could just do 5 times 11, which is the same thing. Madison's agreeing, good, we're happy with that. So, now if you type 5 right now, you're going to have a bit of an issue, because unlike your computer and your smartphone, your TI is set in overwrite mode, not insert mode. So, in order to put the 5 right there, I'm going to press second delete, which is that now turns it into insert. Welcome to 1984, just so you know. Or Pac-Man and Duran Duran.
Insert.
Nothing wrong with Pac-Man or Duran Duran. Second delete. And if you look above the delete button, it says INS, that's insert.
Does that change it for good, or?
It changes it until you press the arrow buttons or the enter key. So right now, you can type, Kirsten, thank you. You can type 5 times. And you see how it pushed everything over to make room for that? Now you're still in insert mode, but what I want to do now is I want to switch over to that 10, and I want to put a 19 times that 10, don't I? Because 19 of you said 10.
Yes.
So I'm going to scooch, when I say scooch, sorry. When I say scooch, I mean left and right.
Parentheses around.
Around.
The 5 and the 11?
Yeah.
Let's come back to that question, Kirsten, if that's okay. I do want to answer that question. You're Tori, Kirsten's here. Tori, Kirsten, I'm going by location here. We'll come back to that question. I want to answer that. It's a very important one. But first, I'm going to put the multiplications in.
Okay.
And then we're going to debate that question. Okay? I'm going to scooch over. Now, did you notice as soon as I scooched, the cursor changed? It went from being kind of hollow to being a solid rectangle blinking. It's now in overwrite mode again, which means to answer Kirsten's question again, you have to reset it back into insert mode. So second delete, 19 times the 10. Good so far? Scooch over again. How many kind of hashs do we have?
3.
We have 3 of them. So insert 3, 4 nines. And everything else is 1. So 10.75 you can just leave as it is, 9.5 as it is. So a great question came up. Do I have to put all those multiplications in parentheses?
You shouldn't have to, right, because the calculator knows to automatically multiply first.
I like this, Crystal. Why does it know that?
Because that's just.
I hope we're pointing at them.
No.
That's just true. Because it is,
Manipulating
Roll.
math.
You have 2 math degrees. How don't you know this? It's because it's called what? Order of operations. Multiplications happen before addition, so it'll know to multiply the 5 and the 11 before it adds the next 19 times 10 and so forth. I got a question for you guys before I press enter. Are these necessary?
Yes,
Right there necessary.
yes,
Is this necessary?
yes.
Believe it or not, the one on the bottom is not. I put that first one in because I thought I was going to put in 5 plus 19 plus 10 plus blah, 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 and then you guys corrected me because I forgot the 1 and then I added it in my head. So that 33 doesn't have to be in parentheses. Parentheses force the calculator to do a certain computation first. There's no computation down there. It's already been done. It's 33. I thought I was going to tell it to do a computation, and then when you guys corrected me, I kind of just did it in my head. Does that make sense? So this is actually unnecessary down here, but this is very much necessary right here, isn't it? Because if you don't have that there, it's going to do this division before it does those additions up there, and you don't want that to happen. This is where I wish the TI, and some of the newer ones actually do this. Is anybody's TI showing them a fraction? There's a long fraction bar, and it's got a bunch of stuff in the top and the bottom. You can set some of the newer ones up like that, and it's nice, because you can actually visually see the fraction that you will want to be doing manually, but mine isn't set up that way. Okay, you ready? Uh-huh. Uh-huh. So, on average, we guessed that the roof is approximately 10 feet. Does that make sense? Based on our guesses, it sure does. That 1.8 was making me nervous. Because the 1.8, I'm looking at our guesses, and the smallest guess we had was 9 feet. If the smallest guess we had is 9 feet, the average can't be at 1.8 because it has to be within our guesses. That's the kind of the definition of an average. It has to be kind of within our guesses. Does that make sense-ish? Makes sense-ish. Could we? Now, I like doing it this way, actually, the actual calculation, because it is important to calculate an average. What academic average is this tied to? What academic average is this tied to? And actually, the word average is used in it, although you don't often use the word. You often use its initial A. Your G, tell me your name. Cameron, thank you. Your GPA, known as your grade point average. Tell me your name again. Asani, thank you, friend. Grade point average. They do this. This is what your grade point average, I mean, you don't use 10s and 9s. We could also if you could, right, instead of 4s. But this is how your grade point is calculated. Your grade point is calculated. You have these, which are called your credits. So this class is a 4-credit class, HHP, total fit, 1 credit, even though it's the hardest 1 credit you'll ever take in your life. You know, your library studies is 2 credits, your history class is probably 3 credits. So you've got these 1s and 2s and 3s and 4s in this column. And then you've got your performance in the class over in this column. So if you get an A, you get a 4. If you get a B+, you get a 3.33, I think. You get a C-, you get a 1.67. So you got a bunch of numbers in this column, and a bunch of numbers in this column. But if you get an A in this class, you don't just get 4 grade points. You get 16, because it's a 4-credit class. You get 4 times that 4 for the A, you get 16. So essentially, when you calculate your GPA, the numerator of that is your credit loads times the value of whatever that class grade you got was, whether it's a 4, a 3, a 2, or 1. Looks like it's 4 or 3. And then the bottom is your credits added up. So you have a 16-credit term or a 12-credit term, your denominator becomes that. Does that kind of make sense? A lot of students inadvertently calculate their GPAs incorrectly because they think, oh, I got an A, I got a C, and I got 2 Bs. That means I got a B on average. Not if that C was in a 5-credit class and that A was in a 1-credit class. Because that C counts 5 times as much as that A. So you can't just cancel the A and the C and call it good. Is that believable? If that isn't crystal clear right now, that's okay. That's okay because we'll get back into that as time goes on and as we kind of develop this class together. It has everything to do with max. I promise you we'll get into that too. Hey, I want to find out if we're right. May I have a volunteer to measure the bottom of the hole to the ceiling? Let everybody jump at once. There we go. There we go. What do we got here? Get to the drywall. There we go. How we doing?
9.
9 feet! We consistently overestimated by a foot. Is that a big deal?
You know, I was right.
I was talking about average though, my friend. Thank you, Kirsten. Thank you very much. 9 feet. I would have, honestly, without seeing myself with reference to it, I would have guessed 10 as well. I would have overestimated as well. Very interesting. 9 feet. We were overestimated on average, quite a bit overestimated. We were in error. What percent error were we? What percent error were we?
10%.
Depends on how you define it. If you define it as the true height was 10 or 9, and we were off by a foot, we're actually like 11% error, right? 1/9. We were off by a 9. But if you define it as out of 10, it's 10%. It's 10%-ish in error. Is that a big deal? Why could it be? Why could it be a big deal?
I'm just thinking it's not a big deal because it's an estimation.
Well, yes, but when could that estimation get you into trouble if you tried to use it somewhere?
Because if you're trying to build a wall,
Or an entire building's worth of these classrooms or offices, and you overestimate by a foot across all those metal studs, which are really expensive. Really, or a spaceship?
Yeah.
Yes, I was thinking. I was thinking more like in this building's terms, but yes.
Well, in the international, like, so, one group was, the group
The Mars lander.
they calculated in metric, and the American engineers calculated